In today's video, we'll look at the product and quotient rules, which are in section 3.2 of the textbook. Here's a summary of what we've seen so far. We know a derivative of a constant is just 0, because if you have like y equals 7, the slope of that line is always 0. We have our power rule, that whatever your exponent is, that multiplies the thing out front, and then your exponent goes down 1. We've seen that the derivative of e to the x is just itself. If we have a constant out front, we know we can just ignore the constant to start, take the derivative of the function, and then just multiply that constant back in. And if we have addition or subtraction going on, we can do the derivative of those things individually. So for example, that one up on top there, y prime of this would equal 12x squared. Plus, we can ignore the 2. Derivative of e to the x is just e to the x, so it just comes back as 2 e to the x. So we know that if you have a function plus another function, you can take the derivative separately. Well, will that be true if we are multiplying? Could you just take the derivative separately and multiply the answers? Well, let's test. We know x times x squared is really just saying x cubed. And from what we know by the power rule, we know that derivative should be 3x squared. Well, let's say we had it written as x times x squared and test it with the power, test it with what we have on the right there, saying just the derivative of the first part and derivative of the second part. Well, derivative of x would just be 1. Derivative of x squared would be 2x. 1 times 2x equals 2x. And that's not equal to what we know it should be. So this basically proves that this is not correct. Now, we've seen ways that if you have things being multiplied, you could rewrite it so we can just use the power rule that we have currently. Like the first one there, we could just FOIL this out. We could rewrite it as 5x cubed minus 9x to the 4th plus 15x to the 4th minus 27x to the 5th. And then that's something that we can easily take the derivative with using our power rule. Likewise, the middle one, we can divide everything by square root of x. Now keep in mind, square root of x is x to the 1/2. So when we do an x cubed divided by an x to the 1/2, we'll get an x to the 5/2. Where that is coming from is doing the 3's exponent, the x to the 3rd, and the x in the denominator's 1/2. 3 minus a half gives you 5/2. Then if we did this middle part here, dividing out a square root of x just leaves you -3. And then doing this part here, 5 over square root of x is like saying 5 over x to the 1/2. Well, to bring that up top, we would write it as 5 times x to the -1/2. And then that's something we could even do power rule with. Where we can run into problems is this last one. Okay, we have things being added on the bottom, so we can't just divide them individually. Okay, so we can see we'll also need something for division, and that's what we're going to work with today. The product rule when you're multiplying, and the quotient rule when you're dividing. So first off, our product rule. When we have two things being multiplied together, you take the derivative of the first times the regular function of the second. And you add that to the regular of the first and the derivative of the second. Now, because this is addition there, we actually could do it in either order. So you could do regular of the first, derivative of the second, plus derivative of the first times regular of the second, and it wouldn't matter. When we get to the quotient rule, the order will matter, but for the product rule, it doesn't matter. Now, we saw a second ago, so this x times x squared really is x cubed, and we know that derivative should be 3x squared. Well, now let's try with the product rule to show that we actually will get 3x squared back. So using this product rule, it says do the derivative of the first. Well, the derivative of the first part's 1 times the regular of the second, which would be x squared, plus the regular of the first, which is x, times the derivative of the second, which is 2x. Well, this now would give us x squared plus 2x squared, which in the end would give us 3x squared, which is, in fact, the same thing that we said we should get for our derivative. So this shows us that the product rule will work. Okay, so let's practice one. Again, we could do this by multiplying it out, but we're going to try practicing the product rule. So we'll take the derivative of the first part, so that'll be 10t plus 18 times the regular of the second part, 35t cubed plus 19t squared, plus, now we'll do the regular of the first part and derivative of the second part. So we'll have 5t squared plus 18t, and the derivative of the second part, 35 times 3. That'll end up giving us 105. T to the second. And then 19 times 2 will give us 38. T. Now, if it doesn't tell you to do any different, this is your derivative. Just leave it right like this. Okay? You could multiply it out, and that would be equivalent and combine like terms, but this is your derivative. We did the regular, or the derivative of the first times regular of the second. So think of this as f, think of this as g. We did f prime times g plus f times g prime. And again, because it's a plus in the middle, we could do those in either order. Now our quotient rule. So if you have some function f divided by some function g, we'll do the denominator times derivative of the numerator minus the numerator times derivative of the denominator all over the denominator squared. This one, the order does matter because of the minus. So a little saying to help you remember this. Low d high minus high d low all over low low. So what low means is the thing that was in the denominator, in this case, g. D high means the derivative of the one on top. So in this case, the derivative of f. Minus is just your subtraction. Your high, so high is the regular of the top. D low is the derivative of the bottom. All over, so that's our division. Low low. So that means the bottom squared, the bottom times itself. So low d high minus high d low all over low low. And we'll practice that here. So h prime of x. Again, we're going to do low d high minus high d low all over low low. So we'll start off with low. Our denominator, the regular, is x plus 3. D high, so the derivative of the top, that means, which is just 2. Now make sure you got to have that x plus 3 in parentheses because the 2 is multiplying with it and needs to multiply both terms. So we've done low d high minus high d low. Well, high is just the regular of what's on top. D low, our derivative of the bottom. Derivative of x plus 3 will just be 1 because the 3 goes away. And the derivative of x is just the 1 that's out front. So we've done so far low d high minus high d low all over, so we'll do our division, low low. So that means the denominator times itself, times x plus 3 squared. And again, unless it says otherwise, you can just leave it like this. If you wanted to neaten it up, you could multiply the 2 out. That would give us 2x plus minus 2x all over x plus 3 squared. The 2x and the negative 2x went to 0, so we'd be left with 6 over x plus 3 squared. So that's if you did want to neaten it up. But again, if all it asks for is the derivative, I would suggest just leave it how it is once you take your quotient rule. Your low d high minus high d low all over low low. Now, you don't always have to use the quotient rule. Kind of like in the second example we saw on this page. We could divide everything by x to the 1/2 and make it to use the power rule, because the power rule is much easier. It's less messy. So in this case here, we can divide everything by x. So we could rewrite y as 3x, because that's doing 3x squared divided by x. And then we've got to do 5x divided by x, which would just give us 5. And then this is much easier to take the derivative of. So just because you've got a quotient doesn't mean you always have to do the quotient rule. See if you can rewrite it first in an easier form. So now to summarize all our rules, we had our constant, the derivative 0. Power rule, the exponent comes out front, the exponent goes down 1. Derivative of e to the x is always e to the x. If you have a constant out in front of a function, just do the derivative rule for the function and then multiply the constant back in the end. Addition and subtraction, you can do the derivatives individually. And then the new ones for today, the product rule, when you have things being multiplied, do the regular times the derivative of the first plus derivative of the first times the regular. And again, these can be done in either order. So you could flip-flop these if you want because there's a plus in the middle. Okay, you just need each pair. One needs a derivative, one needs a regular, and then you flip-flop it for the second one. Now, quotient rule, the order does matter. Low d high minus high d low all over low low. So the thing from the denominator times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let's see if we can practice this. So derivative, we've got a product going on. Again, it doesn't matter which order you do it in. Let's say we'll do the derivative of the first thing. Well, the derivative of the first thing will just be 1 times regular of the second plus, we've now got to do regular of the first thing times derivative of the second. Well, derivative of the e to the x is just e to the x. So this is really just e to the x plus x e to the x. So that's our first derivative. For our second derivative now, we're adding, so we can do each derivative separately. Derivative of e to the x is just e to the x. Now the derivative of x e to the x, well, that was in our original. So the derivative of that will just be what f prime of x is. So we know that should be e to the x plus x e to the x because of this line here. And when you neaten that up, that's just 2 e to the x plus x e to the x. And they want us to do the third derivative now. Well, the derivative of 2 e to the x, ignore the constant. The derivative of e to the x is e to the x, then multiply that constant back in, so we get that it's 2 e to the x. Now, you could do that with product rule. Let me just show you over here. If you did derivative of the 2, you'd get 0, times regular of the e to the x, you get e to the x, plus regular of the 2, times derivative of e to the x is e to the x. That goes away, and you get the 2 e to the x back. So that's why you can do it with a constant, because when you do the derivative of the constant part, it'll be 0 and wipe that side of it out. And then, again, this was our original f of x, so we know the derivative of that is just e to the x plus x e to the x. And we can neaten it up now as 3 e to the x plus x e to the x. So let's see now if we can find the hth derivative. So basically, if we can find a pattern to see what our derivative should be. Well, notice the first derivative had 1 e to the x plus x e to the x. The second derivative had 2 e to the x plus x e to the x. The third derivative had 3 e to the x plus x e to the x. So the hth derivative should then have h times e to the x plus x e to the x. So whatever derivative we had, that was just our coefficient of the e to the x. So this next case here, we could do product rule if we wanted, or we could distribute it the square root of t through. So what we're going to do is we're going to do it with product rule, and then we'll show that we could have gotten the same thing by multiplying it out. So we'll have f prime of t, derivative of the first. This is really t to the 1/2. So that'll be 1/2 t to the negative 1/2 times our regular a plus b t. Now keep in mind, a and b are constants here, whereas t is our variable we're taking the derivative with respect to. Then we'll do plus, we'll do our regular square root of t times the derivative of the second part. Well, since a is a constant, that goes away. Derivative of bt will just be b. Okay? Think of if you had 7t, the derivative of it would be 7. So if you have bt, the derivative is just b. Okay, so again, you can leave it right like that. What we'll do is let's distribute the square root of t in the original, and we'll show that the derivatives would end up being the same either way. So we would have a times square root of t plus b t to the 3/2. Where the 3/2 is coming from, it's t to the first times t to the 1/2. So when you add them together, you get 3/2. And actually, we can rewrite this square root of t as t to the 1/2. That'll make our lives a lot easier. So this, when we take the derivative now, becomes 1/2 a t to the negative 1/2 plus 3/2 b t to the 1/2. Because your exponent just multiplies out front, and then the new exponent is one less than it was before. Okay, so just to show you that we would get the same thing, in this one that we did up here, distribute the 1/2 t to the negative 1/2, and that'll give you 1/2 a t to the negative 1/2 plus 1/2 b. We've got t to the negative 1/2 and t to the first, which when you add those, it'll be t to the positive 1/2. And then this is really like saying 1b times t to the 1/2. Because in front of the b is a 1, and we have t to the 1/2. So this part already matches up. We're good there. Well, if you have 1/2 of a b t to the 1/2 and 1 whole b t to the 1/2, that gives you 1/2 of them, which is the same as saying 3/2 b t to the 1/2. Okay, so that just shows you that you get the same by either method. Again, when you do this, like if you're doing product rule, you would just leave that as your answer. Okay, that is perfectly fine. We just did this extra stuff to show you that you get the exact same thing. So let's see another way this could be given to us, where they give us the actual function for the first part, square root of x, but the thing we're multiplying it with is some general g of x. Well, we're doing product rule. So let's do derivative of the first thing. Remember, this is really x to the 1/2. So we'll have 1/2 x to the minus 1/2 times our regular of the second. So that's just regular g of x again. Plus our regular of the first, which is just square root of x, times the derivative of the second, which is g prime of x. Well, they now want us to find in the question, what is f prime of 4? Well, f prime of 4 is saying put a 4 everywhere you have an x. So I'm going to rewrite this part also, because that's really like having the square root on the bottom. That's 1 over 2 times the square root of x. Well, we want x to now be 4 times g of 4 plus square root of 4 times g prime of 4. Well, in this first part, 1 over 2 times square root of 4. Square root of 4 is 2, so this ends up as 1/4. We're told in the original that g of 4 is equal to 2, so that's times 2. Square root of 4 is 2, and we're told that g prime of 4 is just equal to 3. So a quarter times 2 will give us a half. 2 times 3 is 6. So in the end, we get that this is 6 1/2. Okay, now let's look at another example of the quotient rule. So remember the saying for the quotient rule, we have low d high minus high d low all over low low. So y prime will be equal to low, so x cubed plus 6, d high, so derivative of the top, so we'll have 2x plus 1, and the negative 2's derivative is 0, minus high d low. So we'll keep the top the same, d low, so we'll have 3x squared, derivative of the 6 is 0. So we've done low d high minus high d low all over low low. So we'll have x cubed plus 6 squared. Now, if this was a test and all it said was find the derivative, this would be your answer. I would say leave it as it is, okay? Don't make chances of having another error. Just so you get used to seeing what it looks like simplified, because eventually we'll want to when we use our derivatives as a tool. We're just going to go through how you would simplify this. Again, if it was a test and just asked for the derivative, you would want to just leave it as this. So we'll FOIL out this first part. We'll get 2x to the 4th plus x cubed plus 12x plus 6 minus, and now the second part we've got to keep in parentheses because we haven't distributed this negative yet. So the 3x squared multiplies everything to give us 3x to the 4th plus 3x cubed minus 6x squared, and this was all over x cubed plus 6 squared. So we'll go ahead and distribute that negative now. Giving us minus 3x to the 4th minus 3x cubed plus 6x squared. All over x cubed plus 6 squared. And we'll just combine any like terms we have in the numerator. We've got a 2x to the 4th and a negative 3x to the 4th, which will give us negative 1x to the 4th. We've got a positive 1x cubed and a negative 3x cubed, giving us negative 2x cubed. The only x squared we have is the positive 6x squared. The only x we have is the positive 12x. And the only constant we have is the 6. Then that's all over x cubed plus 6 squared. So again, that's how it neatens up, and we'll do some stuff with the derivatives eventually where we'll want to neaten it up. But for right now, if all it asks for is the derivative, this is perfectly fine. So next we're going to find the equation of a tangent line that goes through the point 1, 1/2 e. We know equation of a tangent line means we've got to do the derivative, find the value of the slope at that point, so get a numerical value for the slope, and then use that slope and the point to write the equation of the tangent line. Well, we're dividing here, so we have to use quotient rule. So we'll do low d high minus high d low all over low low. So low will be 1 plus x squared. D high, e to the x is e to the x, minus high, e to the x, d low, which will be 2x, all over low low. Now we want to evaluate this when x is equal to 1. So we'll have 1 plus 1 squared times e to the first minus e to the first times 2 times 1 all over 1 plus 1 squared squared. Well, in this first parenthesis here, 1 squared is 1, 1 plus 1 is 2. e to the first is e, so we'll just have 2e for that whole first part. We've got e to the first times 2, and it's a negative, so minus 2e. And this will all be over 4, because we'll have 1 plus 1 is 2, squared is 4. Well, 2e minus 2e just gives us 0, so this whole thing will end up being 0. So we're just going to have a horizontal line. Horizontal lines are always y equals some number. Well, the y value we need to pass through is 1/2 e. So our equation will just be y equals 1/2 e. Now, if you don't recognize that's a horizontal line, do your regular tangent line equation. We'd do y minus 1/2 e equals our slope of 0 times x minus 1. Well, 0 times anything is 0, so that all wipes out. And when you add your 1/2 e over, you get what we got a second ago, y equals 1/2 e. So if you didn't recognize that right off the bat, you could still just write it as your regular tangent line equation. That's all for today's video. We'll see you next class, period.